Alright, welcome back to Mathematics Nail. We are still on number base part 3. We have looked at example 1 on this part on how to convert numbers from other bases to base 1 to base 10. We said that we are going to follow these steps, and we have actually followed the steps to solve this problem. So we want to look at the second question, still on conversion of numbers from other bases to base 1. So quickly, let's look at the second example. Example 2 on number base factor. So we can now change 1 to 1 to base 3 to base 10. Alright. We still follow the same principles that we followed in the first example. We say that when we want to change a number from other bases to base 10, we take these steps. Step number 1, we take note of the number and the base. Then we assign powers to the digits in the number, starting with power of 0 on the last digit. So we have 1, 2, 1 to base 3. If we assign powers, we have 0, 1, 2, and 3. So we have assigned powers to each of the digits. Then we say use each digit to multiply the base raised to the power assigned to the digits. So we use each digit to multiply the base. The base is 3. What's the power assigned to these digits? It's power of 3. So we give it to that base again. Plus 2 times 3. The power assigned to this is power of 2 plus 1 times 3. The power assigned to this one is plus 2 times 3 raised to power 7. So use each digit to multiply the base. That base should be raised to the power assigned to that digit. So why we have the power of 3? Because this digit here, digit 1 has power of 3. Digit 2 was assigned power of 2. That's why here we have to raise the base to power of 2. So we have 1 times 3 raised to power, this is 27. 2 times 3 raised to power 2 is 9. 1 times 3 raised to power 1 is 3. Plus 2 times 3 raised to power 0 is 1. We know that when you raise a number to power of 0, you are going to have 1, provided the number is not at 0. So 3 raised to power 0 is 1. So if we simplify further, 1 times this will give us 27, 2 times 9 is 18, 3 times 1, or 1 times 3 is 3, and 2 times 1 will give us 2. So 18 plus 27, 27 plus 18 is 45. 45 plus 3 is 48, and 48 plus 2 will give us what? 50. Okay, so 1, 2, 1, 2 in base 3. When you change it to base 10, you are going to have what? You are going to have 50. That's quite simple. Very simple. So we'll take another example. We'll take another example because we need to solve so many examples until we are sure that this is very clear to you. Okay, so let's take the third example on how to change numbers from other bases to base 10. Question number 3. Let's take the third example and then we'll consider another base. Convert 3, 2, 3 is 5 to base 10. Remember, we may just use this. If you don't want to say to base 10, we can say to a binary number. Remember, binary numbers are base 10 numbers. We said that in our first video where we looked at basic terms that are associated with number base. So let's do this. So when we are asked to change a number to binary number, it means that we are trying to convert that number or to change the number to base 10. So still the same inverse approach will be used. So we have 3, 2, 3. So we assign powers to these digits. Okay? Then we use each digit to multiply the what? The base, raised to the power assigned to the digit. So the power assigned to this 3 is 2. That's why the base here is raised to the power of 2 plus 2 times 5 raised to the power 1 plus 3 times 5 raised to the power 1, 0. So we have this. 3 times 5 raised to the power 2 is 25. And we have 2 times 5 raised to the power 1 is 5. Plus 3 times 5 raised to the power 0 is 1. Now 3 times 25 will give me 75. 2 times 5 is 10. And 3 times 1 should be 3. Okay? So we have 75 plus 10 will give us 85 plus 3 will give us 88 plus 10. So 3, 2, 3 in base 5. When you change it to a number, that is in base 10, when you change it to binary number, you are going to have what? You're going to have 88 in base what? In base 10. Okay, so I believe that this is becoming clearer and clearer. But let's take one more question on this, and before we can actually give you some questions to take away. Alright, but we may still extend it to 2 questions, 2 more examples, because we have to look at a case where we may have a decimal point in the number. So let's take another example on this. That should be example number 4 now. Example number 4. Example 4, still our steps. So example 4, we say change 3, 5, 6 in base 8. So base 10. 3, 5, 6 in base 8, change it to base 10. So still the same principle. We use the same principle also. 3, 5, and 6 in base 8. So we assign powers. Okay? This. So we move. We're going to have 3 times 8 raised to power 2 plus 5 times 8 raised to power 1 plus 6 times 8 raised to power 0. Okay? 3 times 8 raised to power 2 is 8 times 8. Remember, it's not 8 times 2. That means multiply 8 2 times. So 8 times 8, that will give me 64. 5 times 8 raised to power 1 is 8. And we have 6 times 8 raised to power 0 is 1. Then we have 3 times 64. When we use 3 to multiply 64, we have 192. When 5 multiply this, we have 40. And when 6 multiply this, we have 6. So when you add 192 plus 40, you have 232. And 232 plus 6 will give us 238. So 192, 40, and 6. This is 8, 9 plus 2 is 3. And 2 1 here, we have 238 in this 10. Wow, that's quite beautiful. Very good. Okay, so we say we are going to take one more before we can give you a takeaway question. Yes, just one more question, and then we will now have our takeaway question for the day. So let's take example 5. Example 5. Example 5. I have 1 1 1 1 0 1 0 0 1 is 2. Okay, so let's make a statement. Change 1 1 1 1 0 1 0 1 1 is 2 is 10. Wow. I know that the moment some of us will see this decimal points here, no, so we say, how are we going to do this? How are we going to do this? So I'm going to add a statement. I'm going to add a statement here. So let's add it here so that we'll know what to do in this case now. So solution. So let's take note of that. In a situation where we have a decimal point, while converting numbers from other bases to base 10. The digits after the decimal point will be assigned negative powers. So, in a situation where we have a decimal while converting what? Numbers from other bases to base 10, the digits after the decimal point will be assigned negative powers. So it means that in this case now, these digits after the decimal point will take what? Negative power. So that one will not make the mistake of assigning 0 here, 1, 2, 3. No. The digits after the decimal point will be assigned negative powers. So let's now apply that and solve this equation. I believe that the whole principle is clear now, the steps, so we can comfortably wipe it and continue with our equation. So we have the solution to this now. We have 1, 1, 1, 1, 0, 1, 0, 1, 1. So if you assign powers, this is 0, 1, 2, 3, 4, and 5. That's the power assigned. So the normal powers will be assigned. Let's make this clearer. 1, 1, 1, 1, 0, 1, 0, 1, 1. So let's assign powers. Normally 1, 0, 1, 2, 3, 4, and 5. Then this one will take minus 1, minus 2, minus 3. That's the essence of this statement. We say that when we are dealing with a case where we have a negative power, then we are going to assign, when we are dealing with a situation where we have a decimal point, we are going to assign negative powers to the digits after the decimal point. So having done that, we can now begin as equals, this whole of this will give us 1 times 2 raised to the power 5, this times the base, raised to the power assigned to the digit, plus 1 times 2 raised to the power 4, plus 1 times 2 raised to the power 3. This space may not be enough, plus 1 times 2 raised to the power 2, plus 1, okay, 0 times 2 raised to the power 1. We continue from there, plus 1 times 2 raised to the power 0, plus 0 times 2 raised to the power negative 1, plus 1 times 2 raised to the power negative 2, plus 1 times 2 raised to the power negative 3. So 1 times 2 raised to the power 5 is times 2 raised to the power 4, times 2 raised to the power 3, times 2 raised to the power 2, then power of 1, power of 0, then this negative powers now follows. So we move down. This implies 1 times this will give us 1 times 32 plus 1 times 16. We know that 2 raised to the power 5 means multiply 2 into 5 times 2 times 2 times 2 times 2 times 2. So that's 2 times 2 into 5. That will give us 32 plus 1 times 2 raised to the power 3 is 8 plus 1 times 2 raised to the power 2 will give us 4 plus 0 times 2 raised to the power 1 is 2 plus 1 times 2 raised to the power 0 is 1 plus 0 times 2 raised to the power minus 1 is 1 over 2 raised to the power 1. That's what it means. Then time plus 1 times 1 over 2 raised to the power 2 plus 1 times 1 over 2 raised to the power 3. Now, this, the fourth law of indices, when we have a negative power, when the power is minus, it's just the reciprocal. Just turn this upside down, 1 over the number raised to the positive power. So to remove this negative sign, we introduce this 1 over. That's the law, one of the laws in indices. We are yet to do indices. By the time we do the laws of indices, now it will become clearer. So when we have negative powers, that's how to remove the negative power, find the reciprocal. Okay? So we move further. 1 times this is 32 plus 1 times this is what? 16 plus 8 plus 4 plus 0 plus 1 plus 0 times the whole of this will give us 0. Okay? Then 2 raised to the power 2 is 4. And 1 times that will give me 1 over 4. 2 raised to the power 3 is 8. So 1 times that will give me 1 over 8. So let's add the whole numbers. 32 plus 16 will give us 48. 48 plus 8 will give us 56. 56 plus 4 will give us what? 60. 60 plus 1 will give us 61. So we have 61 plus 1 over 4 plus 1 over 8. Now, it's possible we can write this in terms of fraction, or we can also write it in decimal. Because I know if I change 1 over 4 to decimal, I'm going to have 0.25. And if I change this to decimal, I have 0.125. 0.125. So by the time you will add these two, you are going to have 61.375. 61.375 in this term. Or you can add these two as fractions. Yes, you can add these two as fractions. You know, when you add these two as fractions, what are you going to have? You're going to have about 3 over 8. So this can still be written as, you add this and this, you have 61 over 3 over 8. Because when you add 1 over 4, remember how we add fraction, plus 1 over 8. We're going to have 8. 4 divided this is 2, times that is 2. 8 divided this 1, 1 times this is 1. So we have 3 over 8. So 1 over 4 plus 1 over 8 will give us 3 over 8. So when you add 61 to it, you have this. Or you can change this to decimal, change this to decimal, then you have them, and then add. So what it means is that 1, 1, 1, 1, 0, 1.011 is 2. It's the same thing as 61.375 in base 10. Or you can say it is 61 over 3 over 8. Wow, that's beautiful enough. That's beautiful enough. Okay, let's just give you a takeaway question so that you can enjoy as you grow out. Now, this example 5 that we just saw, example 5 that we just saw. So, takeaway question now. So let's dwell on that. Well, change the following to base 10. Change the following to base 10. So, wow. That's 1, 1, 2, 1, 1, 2, 1, 1. Let's put 1 in this side, so that's 1, 1, 2, 3, 4, 5. And finally, let's look at the multiplication here. And let's see a situation where we have another decimal. 1, 3, 1, 2, 1, 2, 1, 1, 1. This. So let's change this to base 10. All these numbers, let's change them to base 10. This one is in base 2, this one is in base 3, this is in base 4, this is in base 5, this is in base 2. Just convert them to base 1, to base 10. Alright, so far so good. I believe that you have mastered how to convert numbers from other bases to base 10. In our previous video, we we looked at how we can change numbers from base 10 to other bases using continuous division. And I know by the time you enjoy this takeaway question, you will now know whether you have actually mastered this concept. When we come next time, we shall be looking at other aspects of number bases that will be carrying out basic operations like addition, subtraction, multiplication, division, evaluation of powers, and evaluation of roots using other bases. Yeah, that's what we're going to consider before we now look at the last aspect, which is equation involving number bases. Don't go too far. Remember, you need to take a meal